Hello friends, welcome back to my channel FRM Unplugged. So today we will be continuing with our question bank series for paper 2 of FRM part 1. The last time we did a few problems on Bayes theorem on probability, and today we will be doing some numericals on the chapter random variables. At most we can expect one question from this chapter. There will never be two questions. There can be at most one, and it's difficult to predict the trend, but usually they have been kind of alternating between keeping a problem from this chapter and skipping it. But overall, from the understanding point of view, it is better if students can understand this concept, because this is very fundamental and this will get used in the various papers like paper 3 and paper 4 and even in FRM part 2. So it's better on our part to be familiar with the content. And we will go LOS wise. And we'll see each LOS if there is any scope for numerical, and if there is any, we will try to solve a couple of the numericals. So if we go to the first one, first LOS is basically describing and differentiating a PMF and a CDF. Obviously this is quite theoretical and there are lesser chances of having any numerical from this LOS. So we will skip this. We will go to LOS 2. Okay, so LOS 2 is basically applying the concept of mathematical expectation of a random variable. Okay, now this is one question which is there in probably either in previous GAR papers it was there, or it was there in Miller's statistics books. Okay, so let's see what this problem is. Now it has been given that fx, y is equal to f of x is equal to x plus 5 whole cube plus x square plus 10x, right? Then we just have to break it. So a plus b whole cube formula we have to use. X cube plus 125 means a cube plus b cube plus 3ab, 3 into x into 5, 3 into x into 5, x plus 5 plus x square plus 10x, which is equal to x cube plus 15x square plus x 16x square plus 75x plus 10x is 85x plus 125. So the expectation of y is equal to expectation of x cube plus expectation of 16x square is what? 16 into expectation of x square plus 85 into expectation of x plus expectation of 125. Now just plug in the numbers, right? Expectation of x is 4, so 4 cube is 64, 4 cube is 64 plus 16 into expectation of x square is 9 plus 85 into expectation of x is 4, 85 into 4 plus expectation of a constant we know is the constant itself, 125. So you do the math and you get the answer. So in the interest of time and for the sake of brevity, in many of the problems I will not go to the last step in finding out the answer. I will rather focus on the process, which will make things clearer, and we can cover more material if we kind of skip at least the last step where you can do it from your own calculators, right? So this is how we have to apply the formula to get the mathematical expectation of a random variable. Now if we go here in the next LOS, so in LOS 2 I think one problem is sufficient, and there is another LOS where the expectation of a plus bx, expectation of ax plus bx square, those kind of where we have to use the formula of expectation of ax plus by or variance. So in that LOS also we will cover. So from this LOS, this one is sufficient. Okay, now we will go to the next LOS where it describes means it's all about the 4 common population moments. So it's population moment, just keep this in mind. It's not a sample moment, it's a population moment. So the 4 population moments are mean, variance, skewness and kurtosis. Okay, now just see here, this is we have to calculate the mean, median and mode of the year-end portfolio value, right? So what is given is, so there are, in one portfolio there are 2 bonds, right? Sorry. So one bond is worth 1000, another bond is worth 1000. This can become 1000, sorry, this can become either 200 or can remain 1000. This also can become 200 or 1000. So what is the probability? That probability of the portfolio value is 400 is when both defaults. So when both defaults, it is 0.220. Similarly, probability that the portfolio value is 2000 is how much? When is the portfolio value 2000? When neither of the bond defaults and each one of their value continues to be 1000. So what is the probability here that both the bonds survive, which is neither bond default? This is 0.45, right? So now we have to find the mean, right? So so is there any other portfolio value that can happen apart from 400 and 2000? Answer is yes. When will that happen? That will happen when one of the bond defaults and the other doesn't default. So in that case, one bond will be worth 1000 and one will be worth 200. So what is the probability of this? Since 400, 2000 and 1200 are exhaustive events, this probability of this 1200 is 1 minus sum of 0.45 and 0.20, which is 0.35. So what is the mean? Mean is 0.20 into 400 plus 0.45, sorry, 45 into 2000 plus 0.35 into 1200. Just plug in the numbers, you will get the answer. This is the mean. Now, what is the median? Median is what? Let's say if we arrange it as in ascending order, 2000. So this is the median. And what is the mode? We all know mode is the one which occurs the maximum number of times. In this particular case, the bond value of which portfolio value occurs the highest number of times, the maximum frequency, it is this 2000. So 2000 is the mode. So this is how we'll kind of do these kind of numericals. Next, if we look at the other one, okay. So here just okay, let us come to this next question. So we all know that a derivative has the value of the derivative can fluctuate. So what we have been told is, sorry, probability that D is equal to 10 is equal to 1 by 2. Probability D is equal to minus 10 is also 1 by 2. So we are asked to calculate the standard deviation. Standard deviation is nothing but square root of variance. And what is variance? Variance we know is summation of x minus mu whole square, expectation of, right? So is equal to 0.50 into, because the probability is each time is half, which is 0.50, into the deviation from the mean. So the mean is 0. So 10 minus 0 whole square plus 0.50 into minus 10 minus 0 whole square is equal to 100. So here we have seen that the mu is 0. So why is the mu 0? Mu is 0 because what is the expectation of x? Mu is expectation of x, right? Is equal to 10 into 1 by 2 plus minus 10 into 1 by 2 is equal to 0. So since the probability of plus 10 and minus 10 is both the same, so I mean we could do this, but once we do some practice, no, there will not be much time in the exam. So whenever you have this, so intuitively you should immediately think that okay, for expectation it will cancel out because it is summation of x fx. Now let us go to the next LOS. So here it is about the difference between a probability mass function and a probability density function. Okay, so this is one important sum. Just look at this very carefully. Okay, so all we have been said is probability that x is less than equal to 8 we have to find out, right? So let's say this is the kind of just any cumulative distribution. It is bounded by 10 and 6. So 8 is somewhere here. So what is x less than 8 is area to the left of 8 minus area to the left of 6, right? So now here we are using one formula for integration. There have been instances where integration numericals have been asked. So I will cover this separately. So just be aware of some of the basic formulas for integration, like integral x dx is x to the power 1 plus 1 by 1 plus 1. So x square by 2. Integral x cube dx is x to the power 3 plus 1 by 3 plus 1. So like that, we just need to be, we don't need to go very deep, but at least know these formulas, especially for continuous random variable, where so in continuous random variable you have to take the help of integration. So here all we have to find out is from 6 to 8. So because we have to get this area, right? So 6 to 8 fx dx, right, is equal to 6 to 8, what is a into x into dx is equal to a x square by 2, 8 and 6 is equal to a into 64 by 32 minus 18 is equal to 14a. Now this is 14a. So what is a? So we all know that this area, this entire area between 6 and 10, this is, the area is 1. So 6 to 10, a into x dx is equal to 1. Therefore a x square by 2 is equal to 1. Therefore a into here it is 10 and 6. So a into 100 by 2 is 50 minus 6 square is 18 is equal to a into 32 is equal to 1. Therefore a is equal to 1 by 32. So here if we calculate 14 into 1 by 32, you do the math, you will get somewhere around 0.44. So which is 43.75. So B is your correct answer. So the next part of this problem is, we have been asked what is the variable's expected value. So expected value is nothing but, expectation of a random variable is nothing but summation of x into fx, right, is equal to, for summation we will do here integration. What are the values to which this random variable can take? It is from 6 to 10. And then what is fx? A into x dx, right? This is already given, right? This is this fx, right, is equal to a into x cube by 3, 10 and 6. A is 1 by 32 into 1000 by 3 minus 216 by 3 is equal to 1000 minus 216 by 3, which is how much, into 1 by 32 is equal to 784 by 96. So this is the answer. This is the expectation of the random variable, which is around 8 point something. Coming to the last LOS, which is the LOS, the last two, the LOS 5 is again describe the quantile function and quantile based estimators, and the last LOS is the effect of linear transformation. Like we did a similar problem in LOS 2, just an extension of that we have to do here. So this is very simple. X1 is equal to sigma y plus mu, and it is given that, so they have purposely given these values to confuse us. So expectation of x1 is equal to sigma into expectation of y plus mu, right, is equal to sigma into 0 plus mu is equal to mu. Similarly, expectation of x2 is equal to expectation of sigma y plus sigma mu is equal to expectation of sigma y plus expectation of sigma mu is equal to sigma into expectation of y plus sigma into expectation of mu is equal to expectation of y is 0, so this is 0, plus sigma into expectation of constant is a constant is equal to mu sigma. This is the answer. So these are fairly simple questions, but just keep in mind that this kind of questions can come, and this kind of they will try to confuse us by giving this mean and variance also as one of the constants in the equation. So we just need to be mindful about that. I think with this we have covered most of the numericals for random variables. There would be other numericals, but those would be just an extension of this, and in some confusing form it will be given. That's all. So with this we can safely assume that we have covered most part of the random variables for the numericals. Thank you.